Okay, so what's the name of this function? The name of this function? Linear. And what's the domain of a linear function? Okay, so a lot of people made this mistake on their mastery check, so let's go over this. For domain, all right, guys, let's go. Domain, it's going to be negative infinity to positive infinity. Some people on their mastery check put infinite to infinite, right? You need to make sure that you put negative infinity to positive infinity. Range is going to be the same thing. Y'all ready? Okay. All right. So now we've got intervals of increase and decrease. Does it decrease at any point in time? No. Okay. Interval of increase, it increases the entire time. Okay, so it's going up the entire time. Okay. On the in behavior, we haven't talked about this a whole lot, but on the right-hand side, is it going up or down? Up. So it's going to go to positive infinity. On the left-hand side, is it going up or down? So we're going to say negative infinity. The next one is called what type of function? Absolute value. Okay. Our domain is going to be negative infinity to positive infinity, just like the last one. But here's where it changes. We have a range of 0 to positive infinity. Now on this one, we've got a decrease and then we have an increase. So with the decrease, it's going to be from negative infinity to 0. Okay, notice how I went from negative infinity to 0. We're looking at our x values when we're talking about increasing and decreasing. For the increasing part, we're going from 0 to positive infinity. Looking at our in behavior, as we go to the right, is it going up or down? As we go to the left, is it going up or down? Look at the in. Yep. Okay, so remember with in behavior, it's almost as if you were standing in the middle and you were looking to the left and right. So on this last one, we've got square root. And domain is going to be from 0 to positive infinity. My range is also going to be 0 to positive infinity. And it's increasing the entire time from 0 to positive infinity. And it's never decreasing. As we move to the right, is it going up or down? Up. As we move to the left, where is it going to? 0. So if you weren't here on Friday, this is what we were talking about, arithmetic sequences. So what that is a sequence where there's a common difference between the consecutive terms, okay? So either the numbers go up or they're going down, but it's added or subtracting a number. Okay, so for the first one, find the common difference in the first number in the sequence. So what's the common difference between these? From 1 to 8, how much of a difference? 7. Does that work for each one? So like 8 plus 7 gives me 15, 15 plus 7 gives me 22. So that works. Okay, what was our first term? Okay, cool. Can you take a moment? Can you try these two? All right. So what was the common difference on the second one? 10. Okay, so it's went up by 10. And then what was our first term? 2. Okay. What about the next one? Negative 9. Does everybody agree? Okay, and then what was our first term? 8. Fantastic. Now, the next one, same thing, finding the common difference and finding the first number in the sequence. Go ahead and try those 3. Take like 30 seconds. Check your work. So on this one, what was the common difference? Bless you. All right, in the first term? 18. Fantastic. Next one? 8. Okay, in the first term? 40. Next one? 2. And then the first term? 8. Okay. Last week, we talked about the explicit formula. Okay, just a reminder on that one, we have this equation or this formula, right? We recognize that. We also have something called the recursive formula. So let's talk about that. So the recursive formula is this guy right here. It's almost the exact same thing, except what this is saying is use the previous term to find the next term. Okay. So for instance, on this one, it says write the recursive form for each sequence. Okay, so in the recursive formula, you're going to say a sub n equals a sub n minus 1. And then you're going to find the difference. What's the difference between 1 to 8? Okay, so we're going to plug 7 in there. And then we have to establish that the first term is 1. And that's all we do for the recursive formula. For the explicit formula, what we did was we say a sub n equals a sub 1, which was 1, plus our difference, which was 7. And we said times n minus 1. And then we made you distribute and simplify, right? But this is all we do for the recursive. You have to pay attention to, is the question asking you to write it in recursive, or is the question asking you to write it in explicit? You got to read, okay? Because it'll ask you for both. Go ahead and take a moment, try number 2. See if you can write the recursive formula. So that's this guy right here. Okay, so let's see how you did. We said a sub n equals a sub n minus 1. Our difference was 10. And then a sub 1 was 2. Simple enough? Okay. All right, we're going to try one more. Go ahead and try number 3. Okay, so I got a sub n equals a sub n minus 1 minus 9. Or you could have said plus negative 9. That's okay. And then a sub 1 equals 8. We okay on that? All you're doing is plugging in. Nothing crazy. Okay. Now, the explicit formula is what we talked about last week. So really quick, just a reminder, explicit formula looks like this. Okay. So we're going to look on the back page. So we're going to flip over to the back. And we're going to do this first one. We're going to write it out in explicit form. And then we're going to find the 10th term. So we're going to write the explicit form and find the 10th term. Remember, explicit formula looks like this. We say a sub n equals a sub 1 plus d times n minus 1. So when we're writing the explicit form, what's our first term? 1. What was our common difference here? Okay. And then we have n minus 1. If we distribute that out and simplify, we're going to get a sub n equals 1 plus 7n minus 7. We're going to combine our like terms. And so that's going to give us negative 6 plus 7n. Now they asked us for the 10th term. So we're going to plug in 10 into this equation in order for us to find that. So we're going to have a sub 10 equals negative 6 plus 7 times 10. And when we do that, we're going to get a sub 10 equals 64. Okay, so if we plug in a sub 1, which is 2, and what's our difference? All right, the common difference is going to be 10. When we distribute, we're going to have 2 plus 10n minus 10. When we combine our like terms, we're going to have a sub n equals negative 8 plus 10n. Now, if we plugged in 10 into this equation, we would get a sub 10 equals negative 8 plus 10 times 10. And when we simplified that, that's going to give us 92. So on your mastery check, what they're going to ask you to do is write the explicit form, write the next 4 terms, find the common difference. And the last question is going to be a word problem. Okay. And what they're basically doing is just taking this and saying like, oh, on the first week you spent $1. On the next week you spent $8. On the next week you spent 15. How much are you going to spend on the 11th week? Okay. That's the question that's going to be at the very, very end. Okay. So these are the 4 different parts of your mastery check today. So on this one, it says, after knee surgery, your trainer tells you to return your jogging program slowly. He suggests jogging for 12 minutes each day for the first week. Each week thereafter, he suggests that you increase that time by 6 minutes per day. How many minutes should you jog in the 20th week? Okay, so really quick, we're going to use our arithmetic sequence. We're probably going to use the explicit formula just to help us, right? So what's our initial? How much do we start off with? 12. And what's our difference each time? Okay, so we're going to plug into our explicit formula. That's a sub n equals a sub 1 plus b times n minus 1. So a sub 1, you told me was 12. Our common difference was 6. And then we have n minus 1. Now, what week are we trying to look at? 20. Okay, so we're going to plug 20 in for n. Okay, now you can distribute and simplify if that makes it easier. That's okay. Let me show you that really quick. That's going to give me 12 plus 6n minus 6. Combine our like terms. That's going to be 6 plus 6n. And you told me we're going to plug in 20. So really quick, somebody plug this into your calculator and tell me what you get. So when we plug in 6 plus 6 times 20, what'd you get? Should be 126. Yeah. So 6 times 20 gives me 120 and then plus 6. So it'll be 126. Can you try number 2? So let's see how you're doing on this. What's your first term? And then how much are you going up by? All right, when we plug into our equation, we have a sub 1, which is 240. Our common difference is 110. When we multiply all that mess out, we're going to get 240 plus 110 in minus 110. When we combine our like terms, we're going to get 130 plus 110 in. Now, what week are we plugging in? 15, right? So somebody really quick, 130 plus 110 times 15. Tell me what you get. Okay, cool. 1,780. Now, let's say, for instance, they told us how much money we were going to make, but we wanted to find the number of weeks. Could you do that? Could you work this backwards? For instance, on the next one, let's say that they wanted to know when, well, let's write the explicit form really quick. Let's write the next one's explicit form. Can you take a second? Can you write that out? Okay, so here's my formula right here. Let's say I wanted to figure out what carriage would have 325 passengers in it. Let's say I asked that question. How would I go about solving that? So now I've given you the number of passengers, not the number of carriages. So we're not going to take 325 and just plug it in. What are we going to do instead? We're going to take this and set it equal to 325 and then solve. Okay, so here it is. 100 plus 25n equals 325. How do I get n by itself? Subtract the 100, right? And then somebody said it, we're going to divide. So 325 minus 100 is going to give us 225. And then if we divide by 25, JK. If we divide by 25, what did we get? 9. So in the 9th carriage, we would have 325. Your mastery check, the last question, asked something very similar to this. Okay, so it almost makes you work it backwards. Please make sure that you're careful on what question it's asking. Okay, whether you're plugging it in or you're solving for n. Do we want to try one more? Yeah, okay. Looking at this, let's say I wanted to figure out which grade had 690 students in it. How would I go about solving this? I wanted to figure out which grade had 690 students in it. How would I go about solving this? I would take 690 and set this equation equal to it, right? Okay, so I would take 690, set 50 plus 80 and equal to it. So how do I solve for n? So I need to subtract first. So minus 50, that's going to give me 640. And then I'm going to divide by 80, and that's going to give me 8. So in the 8th grade, there's 690 students. Questions on that? Are we pretty confident? No. What? Do we want to do another one? Is it the writing the equation or is it the last part? The last part. Okay, let me make that last part easy. So let's say I'm not very good at solving. Not YouTube. That's not what I meant to do. Just a habit. Let's say I'm not really good at solving. What I can do is I can take that equation that I wrote and then set it equal to the number that I want. So y equals 690. I'm going to zoom out. Let's see. And I'm going to look at where these places cross over. Watch the magic. So we see that it crosses over right here, right? What's that x value that they got there? I didn't have to solve it all. You see it? You can use Desmos. You only can use Desmos. If you have Mathway pulled up, you have Tiger Math, whatever else you want to use. No, 0. Okay. I'll let you use Desmos graphing though. Okay. Cool. Make sure that if you do it this way though, you say y equals whatever the number is that you're trying to solve for. Okay. Does that help? About everything else. Which part? Like the explicit formula? Explicit. Let's talk about the explicit formula. Remember, with the explicit, we need to know the first term and then the common difference. So what's the first term in this guy? Okay. And then what's the difference? So we see how we're getting negative 10. So we got 8 minus 18. That would give us negative 10. Okay. Now we're going to take this and we're going to plug it into the explicit formula, which I will give you. I will write that up on the board. So a sub n equals a sub 1 plus d times n minus 1. So let's plug in the information that they gave us. So what was a sub 1? 18. What was our difference? Negative 10. And now we're going to distribute this guy. We want to get rid of this parentheses, right? So we're going to distribute negative 10. So what's negative 10 times in? Okay. And then what's negative 10 times negative 1? Negative times a negative equals, okay, so positive 10. And we're just going to bring that 18 down. Is there anything that I can combine? Okay, so 18 plus 10 is, okay. So that's how we write our explicit form, right? Let's say that they want us to find the 20th term, or the 10th term. My bad. Let's say they want us to find the 10th term. That means that in this equation, we're going to plug in 10 for in. So we're going to get 28 minus 10 times 10. So negative 10 times 10 gives us negative 100. And then 28 minus 100 is going to give us negative 72. Does that make it a little more sense? Okay, again, I give you this equation, so you don't have to like memorize it or anything. You just have to know what a sub 1 is and the differences, right?